Welcome to the SDN track this afternoon. We have two presentations in this track. Upstairs on the 38th floor is the security and IP track. So thank you so much for joining us this afternoon. I wanted to take this opportunity to introduce our first presenter in the SDN track. His name is Jeremy Duncan. Jeremy Duncan is the managing partner and IPv6 architect at Tachyon Dynamics. He's got more than a decade, well more than a decade of IPv6, networking, network architecture, data center, and security experience. He participates regularly and presents often at IPv6 conferences like the North American IPv6 Task Force and other events. What really is something that I really respect Jeremy for is his work in the Marine Corps and the work he's done for us there. Putting himself in harm's way to help us protect our freedoms. He's done a lot of work in a wide variety of roles in the Department of Defense for DISA, JIDIC, DTRA, and DTIC. And he currently leads Tachyon Dynamics, doing DoD, UCAPL, IPv6 training and engineering. And if you heard the keynote this morning, Richard Jimerson from Aaron talking about, the fact that many organizations may need IPv6 consulting guidance, Jeremy's definitely someone you would want to talk to about having him help your organization. So with that, please welcome Jeremy Duncan. Thank you.
All right, can everybody hear me? All right, so thanks for coming. What we're going to talk about today is IPv6 capability of Whitebox networking. So to some of you, it may be a foreign term, the word Whitebox, and I'm going to kind of go through that a little bit here. So what I'm going to talk about here is what is Whitebox networking? And then we're going to go into some of the pros and cons to that. And then we're going to talk about the hardware, and we're going to talk about the software, and then we're going to talk about how everything intersects as far as IPv6 and SDN/NCF or NFC. So what is Whitebox networking? So think right here, here's your OEM switch. We're going to talk about who those vendors are. So this is not Cisco, this is not Juniper, this is not any of the other folks that have their own type of switch and operating system. This is actually a bunch of different hardware vendors that actually manufacture their own switch. And their third-party operating system is where it comes into where it gives you a lot of flexibility that we're going to talk about here. So think of it software disconnected from the actual hardware. So you're buying a box, think you're going to buy a server like you would normally buy a server. You're not buying the operating system that comes with it. You just buy the server, and then you get whatever operating system you want on that. So the idea is you're buying that switch or router, and then you're buying the software that actually installs on top of it, or developing your own software that goes on top of that. So the operator decides basically the mix of the two, not the networking vendor. So that kind of disconnects the two now. So if you think about it, the idea that you're going to Dell to buy a switch, they're going to say, hey, do you want our software, or do you want these other vendors' software that runs on that? So some of the big uses like that right now, at this very moment in time, Facebook is using a kind of an amalgamation, if you will, of Wedge and FBOSS, which are CentOS-based operating systems, network-based operating systems. Google uses Pluto, which is a very big switch-like operating system that runs on there. So what are really the pros and cons to all this, right? So you have no vertical lock-in. That means this is the bare metal philosophy. You have control of the system that you're actually putting in. So like I said, right, so hardware servers don't do this. Why should your networking equipment do this? So scripting, this is where SDN comes in, and this is where it's a beautiful whole new world behind your network infrastructure is that you can build out your whole infrastructure with a whole scripted thing even before you rack the equipment. And then by the time you put it in, you push the button, turn the thing on, and then you got a script that runs either through Bash, Python, Ruby, Puppet, and all of those. So it's a very powerful thing here. And then, you build your network, you build to your network, and it's not the other way around. So you don't have to go and shop, okay, these are the capabilities I need from Cisco, or these are the capabilities I need from Brocade, or Extreme, or Juniper, or any of those guys, and then kind of wrap your hardware and your capabilities around what you buy. So this is actually basically avoiding the self-licking ice cream cone, right? So you don't buy, your whole enterprise based on what your enterprise is going to do to you. You want to be able to control what you do for your enterprise. And then the other part of this, right, the largest expense in enterprise IT right now is networking equipment, right? So it's gotten to the point of where we've shrunk the whole data center down to where everything's virtualized except the network, right? You still have to have hardware switches. You still have to have hardware routers. That's not going away with, the promise of NFC and SDN. You still have to have something that plugs into something else, right? So it's, granted, the scale is a lot lower, but you still have to have something there. So what I'm making the argument here on the pros of this is that you now have the capability and the freedom to look at it a different way. So what are the cons of that, right? It's a whole new world now we're talking about. Network engineers can no longer be sectarian about their specific hardware vendor of choice. So you go to school for 20 years and you get a CCIE, they're going to look, I'm always going to go with Cisco or I'm always going to go with Juniper. Now we're looking at a whole idea that now you have to look at other options in this. And so part of that is that operators have to understand the details of their network because they're going to build a whole new network based on equipment they never had, as well as having to really understand Linux. So all of these white box vendors that I'm talking about run on Linux. So there's some form or factor around Linux. So understanding your way around the shell, understanding your way around a lot of the scripting engines that go into the SDN controllers that may be out there, it's very key to that. So who are these hardware vendors? So a lot of the big ones in play right now are Quanta, Quanta, Acton that also sells as Edge Core, Delta that also sells as DNI that also sells as Agema. So don't ask me why. I think it has to do with who they're selling to and what market, but they're all pretty much the same of each other. Then you have Dell. They have one switch right now that they actually sell, which is this S4810 S6000. So that's their one open network switch that they have right now. And then Penguin Computing. They're a whole line of basically white box switches out there. So these are the big ones, right? So there's probably others that will start popping up out there as this becomes more fashionable in the data center. But these are the big ones that actually exist right now. And if you were to go on, say, I think it's actually Whitebox, whiteboxswitching.org, I think is the website. You can actually see and you can actually purchase directly from them. And the costs are substantially lower than what you buy, even for a Cisco 3750G or 3750X on eBay. So now we get into the network OS. So this is that we talked about the hardware, right? So those are the big hardware vendors. It really comes down to three big network operating system vendors. It comes into Big Switch that has their Switch Lite OS, and that's their little logo here. And then Pika 8 that has PIC OS, and then Cumulus Networks that has Cumulus Linux. Cumulus Networks or Cumulus Linux is the one I'm actually doing a demo on that you're actually going to be able to see. Each one of these three actually work three different ways. So they don't all work similar. They all have maybe more connection to their controller and their scripting engines, and then say maybe less to where you have more control over the switch directly from the CLI. But they all sort of prescribe to the ONIE, which is the Open Network Install Environment. And so that's, you think Open Linux, that's the kind of the Open Compute project. It all kind of funnels into that. Now I say loosely because some of these are less conformant or compliant than others. So we'll talk a little bit about that. So kind of the first one I want to talk about, I'm going to kind of go kind of an overview on how the switch and actually the function of the operating system works, as well as rolling into what you're really here for is how well it works over IPv6. So Switch Lite has basically a Switch Lite CLI. It's not a Linux bash. So you're going to go in there and it's probably easier for folks that are used to logging into Juniper to understand how the menu tree functions, as well as the command line set that exist in Switch Lite. Not really Cisco. This is definitely more aimed at kind of junior or Junos network engineers. But it has a big tap / big cloud fabric with basically Switch Lite controls all. So once you have that basically controller in there, it's meant as a limited CLI. So you can do some show commands, maybe a few edits in the configuration, but fundamentally everything's controlled by a controller that actually pushes everything out. So this is one extreme to that, in that everything you do is pretty much done from the controller. It follows the ONIE standard. So when it comes to the capabilities, right? So layer 2, you have the same stuff. You've got VLAN, VXLAN, COS, QoS, then you got PVST, STP, STP, LACP. You have all those basic layer 2 protocols that are supported, as well as a full scheme of IPv6 routing protocols. So if you're taking it from layer 2 to, let's say, layer 3 switch, you have the full Quagga engine that comes in there. So you're going to see Quagga in here a couple of times because it's actually the open source routing protocol engine that uses for BGP as well as OSPF and OSPF v3. So Quagga right now has absolutely no support for OSPF v3 authentication. And that includes either IPsec authentication or the newer OSPF v3 trailers authentication. So that's one thing to be, concerned about, if you will. Management, everything you can do over IPv6, whether you're doing Radius, LDAP, SSH, SNMP v3, they all have good support for that. So all the platforms, even SNMP v3, so that's always good. First hop security, I was surprised to actually come across every one of these platforms have good first hop security from the standpoint of, say, RA guard. So they all have some form, and they're probably using basically the same Linux package that includes in all those platforms, but they do have a good RA guard implementation. So they also have DHCPv6 server if you want to run your DHCPv6 server off your switch or your router, relays, which are more popular, and then obviously stateless address auto configuration support. They all, interestingly enough, also have RA options in Slack. So your standard RD, DNS, RDNSS, DNSS, which is basically all those RA options that are usually not given to you from the router, but will be given to you in this instance, like NTP, DNS servers, SIP servers, all the stuff you normally wouldn't get through Slack. It has that support. As well as full IPv6 ACLs. Most of them, like I said, are actually going to run NetFilter, which is like your IP6 tables. They all run that pretty much from the standpoint of the firewalling / ACLs. One concern right now is no IPv6 multicast routing. So if that's one of your aims right now and actually deploying it out, none of these actually have any support for that right now, it's a little sad. Now, as far as integration with OpenFlow / SDN systems, they have their big network SDN controller. So that's the one that actually runs it. There may be some interoperability they have with a few SDN controllers that exist out there, but this is pretty much the one they give out as far as the operating system that they have. So that's Switch Lite. Now we're going to go a little bit here on Pika 8, which is the other big operating system out there. So it's dual boot. So now you're in a situation where you can either go Pika 8 CLI or you can do custom hardware Open vSwitch. So now you had Is everybody familiar with what Open vSwitch is? Anybody? Show of hands. Okay, so now you think, have you worked on Open vSwitch at all? So now this actually translates well for you because if it's the same configuration. So the same menu structure that exists in Pika 8's dual boot environment with Open vSwitch, it's the same thing. So you either boot it to their CLI or you boot it to Open vSwitch. So same layer 2. There's no real differences between those and the other one. They use a different routing engine, actually, than some of the other two. They actually use an XORP routing engine. So it has the same capabilities, a little bit less, say, than Quagga, but it does have OSPF v3, BGP multi-protocol, all those things. But Quagga is probably the one that I recommend as far as good IPv6 routing. And then the management, right? So you still have your IPv6 management that exists with Radius, LDAP, SSH, SNMP v3, just like the others, as well as, of course, your first hop security with RA guard. Okay, Cumulus Linux. This is one we actually have a good relationship with because we're actually doing the demo that I'm going to have a little later. Is we're actually using Cumulus Linux. So it has no proprietary CLI. When you log into a Cumulus Linux switch, you're thinking you're logging into a Debian server. So it's actually very interesting, very powerful, and very dangerous for some folks that maybe not used to that environment. But their whole aim around basically stripping off any sort of application layer stuff is that you're getting the raw performance of the kernel in Linux. So all the forwarding stuff is done in Linux on the kernel, all of the routing is done in Linux, the firewalling, everything is done based on the core of the operating system. So they basically take that thing down to a bare metal switch. But But it's you log into the CLI and you look like you're logging into a Debian server. So it's very interesting. Again, they also use Quagga. They have good, just like the other ones that use Quagga, OSPF v3 authentication is an issue, as well as equal cost multipath. That actually does have good support within Cumulus Linux. And then IPv6 management, all those hit all the other buttons for Radius, LDAP, SSH, SNMPv3. First stop security, just like we said, on the other ones, they all have good support for that for RA guard. DHCPv6 relay, server, Slack support for RA options as well as the same issue, no IPv6 multicast routing. So that's, of the three, there's no IPv6 multicast routing. So that, I assume, as things get more deployed, and especially as IPv6 is more deployed within the Whitebox switch environment, you'll see that improve. But the same thing with the net filter rules for IP6 tables. Now, what they have is a really interesting integration with a lot of SDN controllers that we know of. So basically, NSX from the SDN/overlay-ish side is NSX. So is anybody familiar in here with VMware's NSX? Used to be Nicira? Is that what it used to be? Anybody know? Is that Nicira? Yeah. And then a lot of the overlay stuff with PlumGrid, Newage, Dirk, I can never pronounce it, but it's, I think, Japanese. So, but they have overlay plugins as well. So yeah, that's what they got. So from a summary standpoint, right? So all your Linux OS environments have, I would say, 99.99% of IPv6 support today. OSPF v3 authentication and multicast routing are a little shaky, but they do have, from the standpoint of everything else, very good support. Lots of hardware to choose from. You want to buy a switch, you can get down to the bare metal, the silicon, and actually do cross comparisons between all 6 of those guys that I was telling you about. So if you wanted to look at performance, you want to do bake-offs with the same operating system, different operating systems, or all switches and all flavors, and there's probably bake-offs actually happening right now. So, but you really only have 3 types of the OS to choose from. So like I was talking about, there was the traditional switch CLI, which you get with Big Switch. So there's Switch Lite. You log in and you're going through a command line tree. And then there's a hybrid CLI/Open vSwitch, which you get with PK8. And then your kind of true, Linux server that does networking, and that's where Cumulus Linux comes in. But all of them have great scripting and SDN API integration. So it's perfect for auto provisioning. So the idea behind this whole environment is not to just be another networking vendor trying to sell money. It's to look at, we're now looking at SDN and network functions virtualization, and now we have a switch that can be controlled by a controller where you can make changes, alterations of flow, and configuration on the fly. So it's the idea of really separating now your control plane from your forwarding plane. It's a great use of something that you're not going to be dealing with proprietary kind of scripting engines like with Cisco, Juniper, and others that you actually have a part of with a lot of these vendors. So with the demo that I'm going to kind of show you here, and I hope you can read my screen. So basically we have 4 switches in this demo. So we have basically 2 spines, two leafs, and they have OSPF v3 adjacencies to them. So I'm going to log in, kind of show you around here. So let me know if you can't see this. Alter this in here. So basically, what we have, is a Linux, CLI. This is as Linux as it gets, right? And, you can do your IF configs, and you can see all your interfaces that are in there. And these SWPs are actually called switch ports. So it's switch port 1, 2, 3, 24 port, 48 ports. They're all differentiated like that instead of your standard ETH whatever, right? And then you have the idea of, if you're, used to typing these commands out, right, you can do your show. Basically, this is basically a show IPv6 neighbor, and you can see the neighbors that are actually attached, whether it be, we have them set up with link local addresses for all the neighbor adjacencies. And then you can, now at that point, go in here and I'm going to go right into my routing engine at that point. So like I said, there's Quagga. If you didn't want to script this and you wanted to go full into the configuration and actually, type that right. You have the full configuration support of actually editing it directly on the switch or using what we used to actually provision this, which was Puppet. So I'll show you a little bit on what Puppet looks like from there. But, it's a full, basically, configuration environment for Quagga that's very interesting. And I'm going to show you what we look at, say, routing. So you can do a show IPv6 route, and you see up here is you have, for example, we have these OSPF routes that are coming in. You'll see this is actually connected routes, as well as these are actually IPv6 addresses on all the loopbacks for all 4 of those switches. So each one of those 4 actually have a loopback attached to that. And let me see, scroll this up a little bit. But you can see it's a very similar thing. So if you're used to Cisco and Juniper, especially from the routing table, it's actually pretty easy to understand as far as Quagga is concerned. So you'll see where those are being advertised, what interface they're coming out of, whether they're connected, whether they're through OSPF, whether they're static. You'll see all that stuff in there. And you just basically exit out of that. But now looking at the Puppet stuff, so who's messed around with Puppet at all from the networking standpoint? Anybody? A little bit? Yeah, I was a little bit too before I put this demo together. It was this whole eye-opening experience. But basically, it's all done through, configurations that are set up in, Puppet, and you actually have SSL connections where you're actually setting up the configurations, you're setting up certificates that are used, and they're actually connecting to each other. Now you're looking at, hey, this doesn't look like it's IPv6 enabled. It's not. However, you can do it, right? Putting the demo together, I just realized we did not set it up with IPv6 on the Puppet itself, but you can. It's an easy setup to actually have it listening on the v6 addresses, but fully configurable via IPv6. So one thing I can do, though, if I go back into Quagga, I can actually, take that back. I'm going to go in there, and I'm actually going to add a route. So you'd say, let's say I want to add another v6 address to the loopback. I would just, IP-6, add 2001, DB8. I really should have typed this out before I did this. And 2:2000:5/128 dev loopback. So you're basically stating I'm adding that to, what did I mess up here? No, you're not supposed to do it from Quagga. Loopback, add 2002. Of course. Oh, yeah, you're right, man. You're right. Good call. We'll get through this. You know what? It doesn't matter, right? So I'm not going to, I messed up my config. I just got to go back into an email to look at it. But basically all you're doing, right, is adding the IPv6 address to the loopback. It populates itself with an OSPF, and you'll see that actually populate. So what I want to do real quick is kind of go to questions, and I will get that command and show you it real quick. If you want. Does anybody have any questions specifically? Yeah, go ahead.
Now you mentioned those 3, you were recommending those 3 Linux distros. Is that because they have the special drivers to handle 48 ports of Ethernet, or could we, could OpenBSD be installed on them, FreeBSD?
There's no limitation on that, right?
Okay.
So the idea is conforming to the Open Network Install environment. So there is a specifications associated with the open computing environment. Mm-hmm. As long as you're following that as far as building out a Linux/Unix environment, as long as it conforms to that and then kind of, gets through that, you can do that, right? And it'll install, it'll function, things like that. But there's a framework right now associated with that. If you deviate from that framework, folks like Google and Facebook have deviated a little bit from that framework because they built their own CentOS environment. But they've, pushed a little bit back into the open compute environment so that people are at least, oh, I see what you did there. We can pull that back into the fork of code. And so. Okay,
so it's really more of staying within the framework, but in theory, if you installed your FreeBSD on it, you're kind of on your own. And
yep, you are on your own, my friend. But yeah, like I said, the world is the limit. This isn't going to stop at 3 vendors, I'm sure. So,
Right.
yeah.
So is there a high availability, quasi-high availability option if you put in 2 power supplies and try to do something like that?
In the switch itself? Yeah, so it depends on the switch. So that's all depending on the hardware, whether there's more high availability, the number of modules associated with it, that's all based on the hardware. So there is, like I said, go through all, there's a few, and I'm going to put up a few resources here you can kind of scroll through, which will kind of pull out all those hardware and software vendors and give you kind of a good flavor and mix. Because I didn't want to dive too much into the silicon as well as the amount of interfaces, but you're going to get stuff that's comparable to the stuff that you would get on the market for 10 gig, 1 gig, 40 gig, 100 gig. Those all exist in the open, in the Whitebox network environment. So, yeah, that was the command. So, anyway, so I added that command in here. I'm going to come back to that before you have any more questions. So, and you'll see that populate here when I do a show IPv6. Right. And you'll see that guy populate up in here. And here he is. So this is the new route that populated in. But if, everyone's familiar with OSPF, right, it's going to get all of those situations that you're going to have. Your administrative distance, cost, all that stuff is associated with it that you're used to seeing from a networking environment. So, and again, this stuff doesn't have to sit on your switch, right? All of those scripting tools are going to pull all that information too. So you'll be able to see, your routing topology. You'll be able to see, neighbor adjacency changes, OSPF v3 neighbor adjacency changes, stuff like that. So it's a really good, setup for that. And like I said, the licensing on this stuff, very cheap. I'm sure there's other vendors, like I said, they're going to be coming out and really hitting it hard on this and being very competitive in it. So anyway, like I was saying, these are the 2 resources to really kind of look in. If you really want to dig into that hardware, a lot of the folks have really kind of done a lot of good, down-to-earth investigation/research into that. Packet pushers is a big one. I'm sure everybody's familiar with who packet pushers are, but those as well as InfoWorld had one on there and stuff as well. So you'll start seeing a lot more of this as more folks are getting involved in software-defined networking and stuff like that. So, anybody else have any other questions? Yeah.
Just out of curiosity, what are like the hardware specs on these switches, like processor, memory, and stuff like that?
It all depends on the switches, man. So you're going to get to, you're going to get your consumer grade stuff that you'd put in your house to stuff that you would enterprise capability, service provided capability. They're all across spectrum fully from one end to the other. So I wouldn't look at it from the standpoint of this is just a lab thing. These guys are very competitive in the data center world. So, yeah.
Any work on application layer forwarding? I guess even HTTP traffic specific forwarding.
So that's actually a good segue to Scott. He's going to be showing some stuff on flows, not on this, of course. I think he's using Open vSwitch, right, and some other stuff. But he's going to be showing a lot of stuff on flows, and you're going to be doing HTTP gets, right? Yeah. So there you go. That's your answer. Wait for him. But one thing to note, though, is that I know we had NFV 6 that has their application that actually can do performance testing. These will run on all of these switches, right? So you basically can run that application, and it runs and does the testing needed for performance to see how well things are going through the enterprise. So it's good. It's good.
Really good presentation. Thank you.
Thank you.
So the hardware vendors, are these mostly data center focused? Are any of these guys looking at like WAN switches, smaller boxes?
So these guys mainly have been like data center, top of rack kind of folks. Top of rack, data center switch. Like when you mean WAN, like setting up a router kind of WAN?
Small office, CPE, that kind of
thing.
thing.
Yeah, like I said, when I said scale, it goes down to the CPE all the way up to the high-end data center. So these guys go all over the spectrum.
Okay. Have you done much? I like the demo a lot. Okay. Have you done much mixing and matching as far as the different vendors and the different software? I just wonder how much playing around with it.
I haven't had a chance to do that, right? So I got Cumulus Networks has been very helpful as far as helping kind of get this kind of presentation going, the demo and everything. It's a beautiful relationship I had with Cumulus Linux with this. So I would love to have kind of an interoperability show of how, the XOR and Quagga, routing would have shown an interoperability. I just didn't really, kind of out of scope for the presentation. But yeah,
okay,
that would be a great idea though.
And so you mentioned three things: ONIE, scripting engines, Puppet. Forgive my ignorance, but are those kind of all the same thing? Are they related, or could you elaborate?
So they all have their different flavors on how they do scripting, right? Puppet is kind of a Ruby-ish, and in fact, I think it is Ruby scripting. You also have Bash if you wanted to build your own scripts. You just SSH into something and write out the commands based on SSH. Python, you can use Python to actually do scripting as well. And there's probably 15 more that I'm leaving off. As far as, and it's really all based on, it comes right actually back to the application engineer who's used to how they do the auto provisioning. So that's where the world of us network engineers is colliding with the application system side. So, getting up on Python, getting up on all of these scripting tools are probably the number one thing to look at training for the future as far as your jobs are concerned. So yeah. But yeah, they all got weird flavors of each other, but they're all basic scripting engines. So, yeah.
So you've gone over what you showed as traditional type CLI configuration. That's just to get it operational, the routing working. But you were saying, so all those scripting is what then is used to program it dynamically.
Right. So basically, I wish I had more faith in my abilities in Puppet, which I don't to this day, to actually have had auto-provisioned it for you while we were looking at it. Would have been a great way to do it. I didn't want the whole thing collapsing in front of me. So, because I'm new to it, right? So I'm new to Puppet. I'm new to the scripting stuff. So I'm used to hitting CLIs. I'm used to hitting, configuration control tools that are just SSHing or using SNMPv3. So this is new to me as well. I would love to, maybe I'll show you that next year. I don't know, but yeah.
Anybody else have any other questions? Okay. Thank you very much, Jeremy.
Thanks. And again, yep. We also put regular blogs up on our site. You can check it out. We talk about Whitebox switching every once in a while and a few other things. So shoot me an email if you've got any questions or any of that stuff. So thanks a lot, guys.